Hello everyone, welcome to another video on solving a LeetCode problem with APL. So today we will be tackling problem number 1777. No, wait, that's a private problem. We're going to be tackling 1365. How many numbers are smaller than the current number? Let's see what this says. It says given the array nums, for each number, find out how many numbers in the array are smaller than that. That is, yeah, sure. So it's just a matter of finding out. Yeah, I just want to compare all numbers in the array with themselves and find how many numbers in the array are smaller than 8, how many numbers are smaller than 1, etc., etc. And when you want to do, sorry, let me copy the example. So 81223. So this is our vector, the vector we will be working with. Now, when we want to do something with a bunch of, when we want to do some operation, in this case, when we want to compare numbers with a bunch of different combinations, it's usually a sign that we want to use an outer product, so the dot, and in this case, the less than or the greater than. We'll have to figure out which one we want to use, because we want to find all combinations of numbers from the vector that give me numbers that are smaller than or greater than themselves. Yeah. So what we can see here is that the first row, so how to explain this? Yeah. So for each row represents a number on the left and each column a number on the right. So what this means is that the first row is the first number of the left argument, which is 8. So it's going to take 8 and see if it is greater than everything in V. So we see 8 is not greater than 8, 8 is greater than 1, 8 is greater than 2, it is greater than 2, and it is greater than 3. Maybe it will be easier if I start out with something that's not V. So this is the numbers 0, 1, 2, 3, 4. So the first row says the positions for which 0 is greater than the elements in V. So notice here, 0 greater than V gives me the first row, then 1 greater than V is going to give me the second row, which is also all zeros, and for example, this row right here, this is 3 greater than V. Notice Z, 0, 1, 1, 1, 0, it's this one right here. So the problem is just doing this, and then summing along the rows, which is just plus reduction. So this is essentially our result. And if we had done the outer product with a less than, then what we would do is sum across the columns, and for that we would do plus reduction, but with the reduction along the first axis, and it would still work. Or we could stick with this one, but then we would need to transpose the array. So this is the same as this. So it's overall a fairly short solution in APL, and so it could just be the sum of the outer products, omega, and then solve V. And there's no point in having this be a diff when it's just that as a tacit solution, because it's just two functions. Even though there's plenty of symbols in here, this is just two functions, because this is a derived function. There's the operator and you derive a function, and then this is also an operator which binds to this. So this is a whole function, and this is also a single function. So there's two functions in here, and this works as a two-train. Therefore, it works as an atop. You can see here these two larger boxes say that sol is just two functions put together. So yeah, short solution in APL. There's probably many different ways in which you can tackle this problem. Just remember that the point of these videos is not to make a comprehensive listing of all of the different solutions, because you can always come up with a different one. This comprehensive listing is what I'll be building with your help in the GitHub repository that you can find linked from the description. So there I try to collect as many different solutions as possible. This was just the first thing that came to mind. So thanks a lot for watching, and I'll see you in the next video.